Hello again. Welcome to another lesson in geometry. Today we are covering section 4.4, using corresponding parts of congruent triangles. So today we're going to find out that triangles are congruent, and then we're going to use that to prove that other corresponding parts of the triangle are congruent to each other. Okay. All right, so underline the correct words to complete each sentence. The reflexive property of congruence states that any geometric figure is congruent to itself. Okay. So they have to be exactly the same. The reflexive property of equality states that any quantity is equal to itself. So they have to be exactly the same on both sides of the equals. So circle the expression that illustrate the reflexive property of equality. So this is the same on both sides. So A equal A we would circle. And 5 plus C equal to 5 plus C we would circle. The one right above it, if AB is equal to 2, then 2 is equal to AB. Remember, this is the symmetric property. We can flip around in equals, but it's not exactly the same statement. And over here, the bottom left, this says the product of the sum is equal to the sum of the products. This is the distributive property, okay? So even though if I distributed it on the left side, I would get exactly the same on both sides, doesn't mean that it is the reflexive property of equality. All right, so circle the expressions that illustrate the reflexive property of congruence. So the bottom two work. Angle ABC is congruent to angle ABC. That would mean that they'd have the same measure. And CD is congruent to CD. That means that they have the same length. Okay. The one above it on the left here, this is the symmetric property of congruence. And over here, this is the transitive property. Is it transitive? Yeah, transitive property of congruence. Okay, so CD equals LM and LM equals XY, so CD is XY. Okay, all right. Vocabulary builder, the word proof. So proof, related word is prove as a verb. So definition, proof is convincing evidence that a statement or theory is true. So in math usage, we're going to say a proof is convincing argument that uses deductive reasoning. Okay, remember deductive reasoning uses statements and other things to prove something true. It doesn't look at just patterns. Okay. All right, complete each statement with proof or prove. In geometry, a proof uses definitions, postulates, theorems, and to prove theorems. Okay. No one can prove how the universe started. And he can prove that he bought a computer because he has the receipt. Okay, on the top of the second page, we have one more review problem here, number 8. It says complete the steps in the proof. And we're given a whole bunch of stuff here about the sides and the angles of these two triangles. And we're asked to prove that triangle ABC and ADC are congruent. Okay, so we're given AB and AD are the same, so that's where they got those marks. We're given BC and DC are the same. That's where they got these two marks. We're given that angle D is congruent to angle B. That's where they got the double marks on the angle. And we're given angle DAC is congruent to angle BAC. That's where they got the single marks on the triangle. Now we're asked to prove the two triangles are congruent, and we're just going to have to fill in the statements and reasons. They go a little too far on this, I think, just to kind of remind you that you can use the definition of triangles to prove two triangles are congruent, and that all the parts of the triangles are congruent. And we'll show that in the picture here, okay? So you can see we could have quickly gone with angle, side, angle, or we could have gone with side, angle, side to prove that they're congruent right now in one step. But they go ahead and get all the parts, okay? All right, so first off, we have AB is congruent to AD, and BC is congruent to DC. That's our given. And then we can do the reflexive property to show AC is congruent to itself. That's the one in the middle. And then we could say angle D is congruent to angle B, and angle DAC is congruent to angle BAC. That was in the given. And then we can say angle DCA is congruent to angle BCA, and that's by the third angle theorem. Remember, two angles in the same, then the third angle is also the same. So this one and this one are the same, okay? And then we could say triangle ABC is equal to triangle ADC, and that's by the definition of congruent triangles. So if all of the parts are the same, then we can use the definition of congruent triangles. So let's show all parts. There's one set of sides two sets of sides, three sets of sides. Okay, here's one set of angles, two sets of angles, three sets of angles. So we proved all six corresponding parts are congruent. Okay. All right, problem number one, proving parts of a triangle are congruent. So let's see. We have BA is congruent to DA in our given. That's this mark and this mark. And we have CA is congruent to EA in the given. That's this mark and this mark. And we want to prove angle C is congruent to angle E. So I would like to get these two angles in the corners to be congruent to each other. Okay. All right, so name four ways you can prove congruent parts of two triangles to prove, four ways you can use congruent parts of two triangles to prove that the triangles are congruent. So these are the four shortcut methods is what they're asking for. SAS, SSS, ASA, and AAS. Okay. I would also say there's a fifth way. We could just say the definition of congruent triangles, but that means we have to get all six parts. Okay, so we usually try to use the shortcut ones. So to prove two triangles are congruent, when you know two pairs of congruent sides already, corresponding sides already, you could just find another side and use side, side, side. Or you could find the included angle and use side, angle, side. Okay, so those are the two shortcut ways. The given statement diagrams show that there are two pairs of congruent sides. We know two of them. Okay. All right, so let's do our proof. So BA is congruent to DA. That was in our given. And CA is congruent to EA. That was in our given also. Okay. And then we have angle CAB. That's not in our given. So angle CAB is supposed to be congruent to angle EAD. So how could we prove that those two are the same? Well, they're vertical angles, and vertical angles are always congruent. So vertical angles are congruent. Okay, you could also say the vertical angles theorem if you want it. Are congruent. Okay, and then we can now say the triangles are the same. So let's take a look at our picture and see why. So we have side, side, angle, angle in between, and then side, side. So that's SAS. So we can just write SAS here. Okay. All right, and then angle C and angle E are going to be the same. And we learned this back in section 1, and that's because corresponding parts of congruent triangles are congruent. And you could shorten this to CP, CTC if you want. So corresponding parts of congruent triangles are congruent, or you could write it out, whichever one you like. All right, let's flip it over and do some more proofs. Okay, on the top of our third page, we have another proof here. And we are given that AB is congruent to AC, and that M is the midpoint of BC. So they have marked AB and AC the same. And we're asked to prove that AMB, so this angle in here and this angle in here are the same. So we don't know them yet, so let me unmark that. All right, use the flow chart to complete the proof. And we have a given that AB and AC are the same. And then we have given that M is the midpoint of BC. And we have the reflexive property here. So the reflexive property of congruence with AM. So we're going to say AM is congruent to itself. Okay, so I went ahead and marked it in our picture. And then from the definition of the midpoint, we could say that BM and CM are congruent. So that should be 3 marks and 3 marks. And that's because midpoint means it cut it in half. So then those two segments are equal to each other or congruent to each other. And now we can see we have side, side, side because we have 1, 2, 3 sets of corresponding sides being congruent. So triangle AMB is going to be the same as triangle AMC. And remember, you need to put your corresponding angles in the same spot. Okay. All right, so by corresponding parts of congruent triangles, we're going to have we're going to have angle AMB is congruent to angle AMC. And that's because once we know the triangles are congruent, then all of their corresponding parts are congruent. Okay, so remember, you can shorthand this part to CP, CTC, corresponding parts of congruent triangles are congruent. Okay. All right, we have a lesson check. As always, pause the video first and then come back and do the lesson and come back and check your lesson check afterwards. All right, so welcome back. We have two parts to our lesson check. One's down here and one's on the fourth page. Name the postulate or theorem that you can use to show the triangles are congruent, and then explain why EA is congruent to MA. So circle the angles that are marked congruent. So right now we have ETA and MTA marked congruent. So circle the sides that are marked congruent. Okay, so right now we have ET and MT marked congruent on here. Now, circle the sides that are congruent by the reflexive property of congruence. Okay, that's the one that's in both. So that's this guy. So that's going to be AT and AT. They're congruent to each other. Underline the correct postulate or theorem to complete the sentence. So this is going to be, these two triangles are going to be congruent by side, angle, side. We have the included angle between those two sides. So this is SAS. Now I'll explain why EA and MA are congruent. So now we want to know, why is this one the same as this one? And that's because corresponding parts of congruent triangles are congruent. In our lesson check on the third page, we have to find the error in a proof that was written here. So we have some given. We have given KH is congruent to NH, so we have one set of congruent sides. And we have angle L and angle M are congruent, so we have one set of congruent angles. And we're asked to prove that H, this point in the middle here, is the midpoint of LM. So if it was going to be the midpoint of LM, then we know that LH and MH should be congruent to each other. Okay, so let's read through the proof. The first line has their givens. So there's nothing in there that's a mistake. That's just writing down this given statements and saying by the given. And then we have KHL is congruent to NHM. That's these in the middle here. So we can put marks on the angles there. Okay. And that's because the vertical angles are congruent. And then they say the two triangles are congruent, KHL and MHN. So they have some problems with this statement. By angle, side, angle postulate. Okay, so there's a couple things wrong in that statement. We'll fix them later. Okay, and since the corresponding parts of the congruent triangles are congruent, then we know that LH and MH are the same by the definition of a midpoint, and that's because H is the midpoint of LM. Okay, all right. So place a check in the box if the statement is correct, or X if it's incorrect. So definitely the vertical angles is good. So this one is bad. Number one, angle side angle works for an included side. We don't have an included side, so that's definitely bad. And the other thing wrong is if you look at the first triangle, it's named KHL. So K starts up here and then goes to the H and then goes to L. And our other one is MHN. M starts in a different spot. This starts with the angle that's marked with the 1, so that should have corresponded with L. So this is also bad. If we wanted to do that, we should have said NHM, okay? All right, so when you name congruent triangles, you must name corresponding vertices in the exact same order, okay? That takes care of this part, okay? To use angle side angle postulate, you need two pairs of congruent angles and a pair of included congruent sides, which we didn't have. So that tells what's wrong with this statement, okay? To use the angle side theorem, you need two pairs of congruent angles and a pair of non-included sides, okay? And that's what we have here. So identify the error in the proof. They used the wrong reason for proving triangles congruent. Okay, and they also put the parts of the triangle in the wrong order. So also put corresponding parts of the triangle in the wrong order. Okay, so we have to correct the error in this proof. So the one statement that needs to be corrected is this one. We need to say which triangles are congruent and how. So we're going to say triangle KHL is congruent to, all right, so since we started with K here, we have to start with N down here, so NHM. And this is going to be by angle, side. All right, that concludes our notes for today. Check off the vocabulary words that you understand. So by now you should be really good with congruent, corresponding parts, and proofs. We've been working on proofs for a while. And if you are not up here, you really need to start getting there because our test is not too far off. I will see you in class next time, and we'll practice more with thinking about if triangles are congruent, then they know that their corresponding parts are also congruent.